Here's example 2 of the moles to moles limiting reactant problems. It says we have methane gas and oxygen gas reacting to form carbon dioxide gas and water vapor. Well, before we do any stoichiometry, we need to have a balanced chemical equation. Our reactants are methane gas reacting with oxygen gas to produce carbon dioxide gas and water vapor. Okay? So not only do we need the chemical equation with the correct chemical formula, but we also need it to be balanced. So let's balance this very quickly. It looks like I'm going to need a 2 here, and I'm going to need a 2 here, and that may be it. 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 2, 4 oxygens. It's balanced now. Coefficients there would be a 1 and a 1. Now, they tell us that we have 13 moles of CH4. And they also tell us we have 3 moles of O2 in a reactor. So they give us amounts of our reactants, of these two starting substances. Whenever you are given amounts for more than one of your starting substances, you need to determine which one is your limiting reactant, which one is your excess. Why do we have to determine our limiting reactant? Because we were given amounts for both of our reactants, both of our starting substances. One of these is going to limit how much product we can produce or how long this reaction can go forward. So we need to determine which one of these is the limiting reactant, which one is going to essentially run out first. So by definition, your limiting reactant runs out, and when it does, this reaction will stop. It'll stop moving forward. So how do we find our limiting reactant? Well, there are many ways to do that. The way that I prefer to do it is this way. You take your starting amount of your first substance and you convert to any one of your products. If you're the limiting reactant for carbon dioxide, you're also the limiting reactant for water. So it doesn't matter which one you convert to. Let's just convert to water. So we're going to figure out how much water we can make from 13 moles of methane. We're not worried about how much oxygen we have. Let's just say if we have plenty of oxygen, how much water can I make from this amount of methane? And then we're going to do the same thing with oxygen. If I have plenty of methane, how much water can I make from 3 moles of oxygen? We're going to also convert to water. And the substance that's going to give me the least amount of water is my limiting reactant. So let's do it. Let's see what we get. We have 13 moles of methane, and we have 3 moles of oxygen. We need the coefficients from the balance equation in order to convert from this substance to this substance. Now don't get tricked. If they gave us grams to start with, we would need to convert from grams to moles first, because the only way we can go from methane to water or from oxygen to water is if we have moles to start with, because we're using the mole ratios as a conversion factor. So because we have moles to start with, we don't need to convert to moles. We already have it. So we can just pull the coefficients straight from the balance equation. The balance equation tells me that 1 mole of methane produces 2 moles of water. It also tells me that 2 moles of O2 produce 2 moles of water. So I end up with 26 moles of water produced from 13 moles of methane, and I end up with 3 moles of water produced from 3 moles of oxygen. Which one of these starting substances, reactant A or B, is going to limit how much water we can make? clearly the oxygen. So what that means is we can identify oxygen as our limiting reactant. Methane is our excess reactant. So by definition, your limiting reactant is completely consumed in a chemical reaction. What does that mean? Well, in this reaction chamber, where I have 13 moles of this and 3 moles of this, the reaction, once these mix, the reaction is going to go forward. And what's going to happen is the oxygen is going to run out first. The oxygen is going to run out once I have formed 3 moles of water. Once the oxygen runs out, there's no more O2 left to react with the methane, so the reaction is going to stop. So your limiting reactant is completely used up, and the excess reactant, there's always going to be some left over because you have an excess of what you need.